then because it's a distributed load, the total weight of this beam on here is 2W, goes in the middle. And how big is it, the beam?
2A.
2A. So, look at here. It's a 2W goes there. The length of the beam from here to there, don't do anything, just watch me.
Yeah.
And if you have a problem, ask me. 2A. So, how much is it per length, weight per length?
W over A.
UDL of that would be a 2W over 2A. Total divided by length, which is going to be W over L UDL. They ask you for the reaction force at the point A and B. A and B. Easy to be done. So this is 2W in the middle. W goes on there, W goes on there. You don't need to even use the condition of equilibrium. Straight away you can anticipate by looking at it. Fact of life. Yes? So in order to cut, how are we going to cut this one? How many ways you can cut this one? You can do a one cut, or for simplicity you can do it 2 cuts. Yes? Okay. Because it's a pin load, I do it in 2 cuts. Yes? Which is going to be 1x bigger than 0 less than a. Shall we do that? And then I'd call this beam. And this is a point of A, point of P is a point of cut, there would be a shear force here, and there would be a reaction force which is already got that W, yeah? And there's a moment going to be here as well, yes? And the distance I cut is called it X. As simple as that. Then I'm going to solve it. So, equation of the shear force for this one is a shear force, is a force, would be S goes up, W goes up, and something goes down here, which is, I have missed it, yeah? I haven't put it there, but you have to put it. Is there any load goes here? I haven't put it. In the previous one I didn't, but in this one I have to do that. Why?
Because it's a weighted beam.
Because it's a loaded beam. Does it make sense to you at all? When the beam is a loaded, before you'll be looking at a concentrated load, at this one is a distributed load. So in the middle there is a one load goes down. How big is it, this load? Any idea?
2W. No,
2W. Okay. From here to here, how big is it?
X.
Every meter of that is a W over
L.
A.
A.
Yes? Should put the A, not L. A. Yes? So become W
X.
over A, X goes down. Yes? And if I balance it, this is goes up, this is goes up, this one goes down, which is going to be a minus of W, A, X goes down, then balance. Is it clear to you? No?
Yeah.
Only when there is a loaded beam. It means there is a wall on top of the beam. Sometimes there is no wall or there is no load on that. How could I explain it to you basically? Can you see it? This is a beam. Up to here, yes? How many meters is from here to there?
2 meters.
2 meters. For half a meter of this beam, I put 1 meter of the load in it. This is a beam, this is a load. So, from here to here is no load. But from here to here is a load. 1 meter of that is a this load in there. Or 2 meter of that is a load. But here there is no load. If I remove everything, there is no load. Unless I put something here, that's a pin load. This is called a distributed load. So this distributed load, when you are dealing with the beam, you would say, hold this one will act in the middle. If I cut this bit of it, which is distributed, from here to here, I got a load which is cut in the middle. Which is this one I cut. Because of these two folder. It's like a wall, or somebody makes something in there.
All right.
Does that make sense? That's called the meaning of the distributed load. I hope you get that.
And so that part we took it from the main way.
And I told you is distributed. Distributed, they showed me this exactly. And every meter of that is a WRA.
Ah, okay.
So, and also, and let's do the moment. Moment about P. P, take a moment. At the point P, there is a moment already. Yes? And let's do the moment about that. This one doesn't make moment, this one make moment, which is make the same direction of the P. If I took this one positive, would be a W, A, X times a distance. What's the distance from here to there?
X.
I call it the X distance.
X.
What would be from here to there?
Half X.
Half X. Make sure you record everything and go home and go over it one more time. This is gonna be a X over 2. So this times X over 2, would it be times X over 2. It's gonna be same direction, positive. And this one, W negative way goes, yeah, times X. Happy? And let's sort out this one. This is a one cut. And then if I make it nicely, M plus, this times that would be WX square over 2A minus WX equal by naught. Let's make another cut. X bigger than 0. I think with the same cut you can go as well, because it's not after the distributed load. I have to go right to the end of the beam. I can do that, yeah. Bigger than A, less than 2A. So again, same thing as this one. Nothing will change. I should have a one cut actually. What's the cut distance of X? How much does it go down? The force wise, how much does it go down? W, A, X. Same things again. That's the only thing, I just changed the distance. It would get you almost same things. It would give you same thing. Just one distance, it would be fine. So I can say from 0 to 2A, I can cut it, yeah? From beginning, instead of I use that, you say from 0 to 2A. Because usually I say, after and before concentrated load, there is no concentrated load, yes? So from beginning to the end, I could say. Because there is no concentrated load. Okay, right. This distance from here to there, let's call it X. And let's work it out. So S goes up, this goes down, this goes up. Moment about P. That's the shear force. That's the P moment. So at the P, there's a moment. This one would be a same direction times x divided by 2. This one minus w times x. Look at that. These two equations are same almost. Just the range is different. This one I took for half of the beam, this one I took for almost end of the beam. Okay? Look at that. This one it gave you, I want to tell you why I said it was right. S is equal W over AX minus W. That's the one equation, yes? And this one it would be M is equal by WX minus WX squared plus positive over 2A. This goes the other side, become negative then. This goes the other side, it become positive. Yes?
Yeah.
And this one, it gave you same equation, look at here. And this is going to give you same equation. Yeah? Can you see the same equation? Yes? I didn't need to go through that, but anyway, I did it. This is a shear force. That's the bending moment. Go to the end of the slide. And now, this is 2A, this is A, this is 0, bending moment, that's a shear force, Newton this one Newton meter. Can you say there is a disconnected? The axis is disconnected from each other, that's why I put it like this. Right. In order to solve that, look at here. I'm going to solve these two equations. Let's solve it for the S. When the x is equal by, we can call it a 0, yes? From 0. Let's start from 0. We can say from 0. From x is equal by 0, what would be a S?
Minus W.
Minus.
W.
When the x is equal by a, S is equal by?
Zero.
When the x is equal by 2a, S is equal by? Put the 2a here.
2A over
A and A, they're cancelling each other. 2w minus w.
W.
Isn't it beautiful? Yes? We call it if. So if the x is equal by 0, let's make it like a w, 2w minus W minus 2W equal this one. WA 2WA minus WA minus 2WA, yeah? If I solve it, when the x is equal by 0, s is equal minus w. 0, start from here. Yes, that's the point. X is equal, this is the x-axis, yeah, or length. X is equal by 0, s is minus w, which is I put here. When the x is equal by a, s is equal 0. So at a, it should be 0 here. Here, 0. Yes? Yes? And you can see here, this is the equation of a straight line. And when the x is equal by 2a, you're going to go w. So that's going to be from here to here w, from here to here minus w, yeah? And
where's 2a? You said x is equals to 2a. Where's yeah, I know, but where's it there? You put it. That's where w is.
yeah, but this is a.
Oh,
X-axis will become a length.
yeah.
This one will become
W.
w, which is
Oh, okay.
force. Zero a,
Oh.
which is x. Okay, let's solve this one. First of all, hello. What sort of equation is this one?
Quadratic.
Quadratic equation, which is equal y is equal ax squared plus bx plus c. C is gone. So m is equal by wx minus w over 2ax squared, yeah? Quadratic equation is going to be a curve. Is a maximum or minimum?
Minimum.
If a bigger than 0 is always, curve is always, always
Minimum.
minimum. If a less than 0 is always, okay, do you understand that? I told you this stuff in the past. Right, can I clear that? So by looking at this equation, is it a maximum or minimum curve? Curve is a minimum or maximum in here? What's the coefficient of the highest power? Highest power is x squared. What's the coefficient of that? The number which is multiplied x squared. What is it? W2a is all number minus. So whole minus W2a is less than 0. So curve is going to be a maximum. Yes? So let's do it. I'm going to solve this one. I can say if they didn't teach you properly this bending moment and shear course in the past. Who taught you this one?
Gavin, I think, taught me many years ago.
Did you use the same method almost?
Uh,
No.
Right.
So he screwed it up. It should be this method and period. You have to design it, model it, solve it, and period. Okay, that's the equation of bending moment. This bending moment equation, Wx, I should tell him as well. I said, this stuff, well, I mean, I don't blame him. If I go and teach the electrical and electrical, I would be screw up 10 times worse than anybody